disconnect and reconnect. Ah, you know what? We're working now. All right, we're recording. All right. You know what? Let me just check the chat to make sure. Yeah, so you guys can see that's great. Will I post the recording afterwards? Yes. So it is recording right now. So I'll share this recorded lecture afterwards on Quarkus. Yeah, I think maybe a good place to start would be just to lighten the mood. My friend sent me this very funny video, quarantine day 6. Yeah, you need some positivity in times like this, I must say. And actually, as I start the lecture, I want to see if I can go in slideshow mode and still see your comments. I can. Okay. Great. So just as we begin, I want to be honest and say that you've probably noticed that last week on Thursday I looked a bit tired, and that's because I didn't get a lot of sleep that night. And to be honest with you, I was a bit anxious by everything that was happening in the news, probably like you, because there was so much going on all at once, right? It was a lot of one of a time kind of incidents, historic stock market crashes, Italy going on complete lockdown, empty market shelves, gyms closing, stores closing, restaurants, state of emergency. And then Donald Trump is president in the middle of all this down south, and it's scary. And I think for me, probably one of the scariest things is that a lot of people were saying there are echoes of 1918 and the Spanish flu, which killed 50 million to 100 million people, and that was back when the world's population was 2 billion, which is pretty scary. But then the more I thought about it, the more I realized, today is not like 1918. 1918 was the tail end of one of the worst wars in history. There was a lot of censorship going on because it was wartime, right? So news wasn't traveling as quickly and as transparently as it is right now. There was a lot of lack of knowledge. We barely knew how viruses worked back then. And most importantly, there was no international collaboration. There was no WHO. Right, we talked about the WHO falls under the UN system. That didn't exist until the 1940s, and part of the reason why the WHO exists is because of what happened in 1918. So, there's a lot to be optimistic about right now, and I figure maybe a good place to start this lecture would be to tell you, just to illustrate how far we've come in terms of our advancement. I want to tell you the story about a cholera outbreak that had changed the world. So this happened back in, I found week 10 lecture slides. All right, I'm going to answer your questions at some intervals later. But for now, let me stay on this train of thought. So in the mid 1800s, in a slum of London in the UK called Soho, there was this particular slum was in the middle of a huge urban migration during the Industrial Revolution. Right? It was primarily inhabited by lower income, lower class people, if you will. They didn't have the best infrastructure, and it was there that a cholera outbreak killed thousands of people in the mid 1800s all the way to 1884. Right, so this picture here on the right hand side shows you the type of environment that people were living in. Now back then, the prevailing theory of how diseases like cholera spread was through bad air, literally. The prevailing theory was called the miasma theory. So diseases spread from dank, stinky places like sewers or you know, from trash or things like that. And because, you know, those smells were particularly strong in poorer areas, disease was in general associated with poverty, right? And, you know, I think I'd mentioned this to you before about malaria. Malaria literally means bad air, right? Which is what miasma is. There's a, you know, it still stays with us to this day in some ways. And this comic here, you know, makes fun of that, makes fun of, you know, how they were trying to find the source of cholera in London. They were just like sniffing around the place, trying to find where the cholera might be. Um, so, um, so yeah, and that was until the hero of the story came into the picture. His name was Jon Snow. It wasn't this Jon Snow. It was this Jon Snow. He's not as handsome, but he saved a lot of lives through what he did in the middle of this massive epidemic. So basically, John was a huge skeptic of the miasma theory. He didn't think that diseases spread through bad air. He thought that it probably spread through water, right? But he wasn't entirely sure how. So what he did was basically exactly what I tell you should do as good engineers is, you know, he hit his boots on the ground and he went out in Soho in that neighborhood and um, and he started interviewing people because back then in this Soho neighborhood, the hospitals didn't really record deaths by location. And again, this was a slum. There were no fixed addresses. So he was basically going around asking people, hey, you know somebody who died next door? And you know somebody who died here? And so he did this, you know, it turned into an ethnographic study of trying to figure out exactly where the deaths were happening. And he also overlaid his map with a plot of where the water pumps were, because the water back then was pumped through hand pumps, right? So there's a pump here, there's a pump here, 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 and so on, right? So you can see here that, you know, right around Broad Street, there's a lot of deaths, right? There's a cluster right here, right? Which led him to think maybe it has something to do with this water pump. But he wasn't quite sure yet. He needed to be a bit more rigorous. So what he went on to do is generate what we today call a Voronoi plot, which is really genius. Now, the way a Voronoi plot works is, you know, for those of you who might not know, basically you start with the pumps because that's your target, right? So you start with your pumps and then you draw these polygons around each pump. Now, these polygons represent basically the limits between which you might be closer to this point or this point. So in this little polygon here, if you're anywhere inside this polygon, then this pump is the closest one to you. So across this dividing line here, if you are somewhere here, then this is the closest water pump. If you're somewhere here, then this is the closest water pump. Right? And he generated this plot by basically walking around and measuring walking times, which was even more complicated than just running a simple mathematical calculation to figure out where these boundaries are. Right? So you could see here that around this pump here, there's a lot of cases, right? There's fewer ones here, there's a few here, but most of them are around here. Right? And when you replot it, you know, using advanced techniques like a heat map, you'll see that right on Broad Street, right, you know, that pump area, you'll see right there, there was a lot of deaths, right? So, you know, John started thinking, you know, maybe I've come across my culprit, and it maybe has something to do with this pump. But being a scientist, he wanted to be even more sure, because, you know, you have like a few pockets here and here and here that got cholera. They're nowhere near this pump, right? And you have places here where this pump was a bit closer, but still have a few cases. So he would actually go to those outlier areas. He would talk to people. He would interview them, and then he would learn, for example, that the people living here have family on Broad Street, so they go visit them often, and they got exposed to this water. Or, you know, the people who were living up here, maybe they were passing by this spot at, you know, in their daily commute, and they drank water from this pump at some point. So he was able to identify, you know, exactly the causes of death. And he was able to trace each death back down to this one pump, which is really fascinating. Um, you know, once he figured all this out, he went on to suggest to the city that they should go to this pump and they should remove the handle, right? And you know, I wish I can tell you that his actions saved a lot of people, but by the point he came to that conclusion, the virus had already, or the bacterium rather, had already burnt itself out in the community. It had killed some 14,000 people. But you know what John Snow essentially did through his study is he basically invented the field of epidemiology, right? If you go to Broad Street, you'll find the John Snow pub. You'll find the pump in front of it. You'll find this plaque that commemorates him for basically creating the field of epidemiology. It's his research that day or that period that laid the groundwork for the contact tracing and the containment protocols, all the stuff that we're doing right now to contain the COVID-19 virus can be traced in some way to John Snow. Now, you know, 165 years after the events of Broad Street, you know, there are still some 1.3 to 4 million cases of cholera each year, which is shocking, right? And you know, most of them occur in sub-Saharan Africa because of contaminated water. And you know, last week we've talked about the technologies that are necessary to tackle this problem. Sometimes they're as simple as you know, chlorine tablets to disinfect water. It could be piped water to houses or taps. Or it could just be oral rehydration salts for people who get cholera, because cholera basically results in diarrhea, and diarrhea results in dehydration, right? So, you know, the next John Snow, you know, will not necessarily come up with some revolutionary new field of study, but he or she will be the one to figure out how you can get these technologies exactly where they're needed to tackle cholera and other diseases where they're currently ripping through vulnerable populations. All right, I'm gonna look at some of the questions in the comments here. All right, so Liam asked, will the slides be posted? Yes, I thought I had. Give me a second. Oh yeah, they did not post. Okay, let's do that right now. File. All right, there we go. It's uploaded now. So I'll give you all just a minute to go on Quarkus to download them and keep up with the slides. Any questions, by the way, while I'm waiting? Really, it'll help me immensely if you comment as I'm talking along. It'll be a bit weird because I have to keep my eye on the chat, but it really does feel a bit weird for me talking to myself here. So any bit of help from you can help make the process easier. Some campuses in U of T canceled final exams. Is there any news for this course? Yes, the final exam is not canceled, but we're gonna have to do it online. We have plenty of time to sort this out so that, it'll be on April 27th. So I think the key thing for me would be to make sure that you are all in the same time zone. So if some of you are in a different time zone on April 27th, just shoot me an email. Yeah. All right, great. If you, again, feel free to interrupt me anytime. I will actually greatly appreciate that. All right. So this was a massive detour from today's lecture, right? The title of today's lecture was Agricultural Technologies in International Development, right? But still, I think this was a fairly important topic to talk about. And like I said, in the middle of all this chaos and uncertainty, feel free to reach out to me. We can talk through it together. I don't know what's going to happen. I can't necessarily give you reassurances, but I think talking through these things and realizing that, when we think to ourselves and don't involve others, we can usually go to the worst case scenario. So, I'm always around to talk. I'm not just an instructor. I'm there for mental support as well. All right. So we're going to keep up with the structure of the last 2 weeks, which is we're gonna focus on the global grand challenges that we discussed. The grand challenges that we need to address in order to help the world get closer to the Sustainable Development Goals. So again, as you recall, the first topic that we discussed was financial inclusion, right? And the technologies that we can bring to the fore to enable people to be able to borrow money, to get insurance, and so on and so forth. The second topic is the one that we talked about last week, which is water, sanitation, and hygiene. And we talked about the huge impact sanitation especially has on health and development and social cohesion and so on and so forth. And we talked about the difficulties, especially in the discussion we're having on the discussion board right now, the difficulties of mobilizing a whole population to take up better sanitation practices. The second global grand challenge is global public health. I think it would have been very timely to talk about global public health technologies, especially given what's going around right now. If you are interested, feel free to email me and I can share with you the slides I had prepared from last year and the year before on technologies for global public health, because that used to be an entire lecture in this course, but we won't be doing it this year. Energy is another one. I think it speaks for itself, and we've talked a lot specifically about electricity and its impact on development. And the last one is food and nutritional security, which is the focus of today's lecture. Now, food security is a tricky thing to define. Because food security to me might not necessarily mean the same thing to somebody else. But broadly speaking, food security can be defined as three things. It's the availability of food, it's the affordability of food, and it's accessibility of food, right? And this is very similar to what Kiki Chan, our guest lecturer from 2 weeks ago, mentioned, right? And on the issue of availability, we already grow enough food for 10 billion people. But the sad reality is that there are still a lot of people who are food insecure, and those people tend to be the very farmers who produce the food that we consume. Right? It's one of those massive tragedies in the world, is that the people who produce the food are themselves going hungry. Right? There's a lot of reasons for that. We're going to talk about some of them today. But a big part of the problem has to do with the fact that incredible agricultural technologies, which we're going to talk about today, are not readily adopted by small scale farmers like the one you see in this picture here. And there are a variety of reasons for that, which again, we're going to discuss. And in fact, if you look at it historically, and the Green Revolution has, again, generated a number of incredible technologies, but they've only benefited, we know now that they've only benefited the well-educated and wealthy farmers, particularly in India. Right? Which is really another example of the law of amplification in action. If you give a technology to somebody who's well-educated and wealthy, they're going to get more out of it than somebody who doesn't have that same privilege, right? So, a lot of food security has to do with how food is distributed, how food is stored, the supply chains for food, and how it can be made better accessible, right? And, a lot of that Kiki talked about in her lecture, but we're going to touch on it again in this lecture, right? So we're going to focus on smallholder agriculture, and we're going to talk very briefly about smallholder aquaculture. I've talked a lot about aquaculture in this course already, but again, it's important because it plays such a huge role in the food security of millions of people in specific countries in Southeast Asia. So it's something that's worth talking about. All right, this part is going to be tricky because I can't stare you down awkwardly till you answer, but I can introduce awkward silences instead. But really, it's not about awkwardness. I really want to make sure that we keep the discussion flowing. So let's pretend like we're in class, okay? So to keep the discussion going, yeah, time to pick on Nishad. All right. When I say a smallholder farmer, what pops in your head? What do they look like? What is their farm like? What is their life like? I'm going to give you a minute to answer these questions because I know it takes time to type and it takes me a while to read the answers. Yep. So I'm hearing they own a small quantity of land, mostly devoted to subsistence. Small pieces rely on family labor. Yes, that's a very good point. See, by doing this, you reduce the amount of work I have to do, so I don't have to repeat all these things again. Minimal assets such as land, livestock, and crop variety. Manual processes, yes. They grow limited food and they don't have modern irrigation systems. Lower access to market compared to large holders. That is great. That literally covers every point that I was going to mention. So when we talk about smallholders, we talk about farmers who typically have their total holdings are about 1 to 5 acres in size, which it's hard for you to imagine, but think of it as the size of like King's College Circle, which seems big to us as a garden, but for a farmer who has to guarantee their income and food security for them and their whole family on a plot that small, every single year, regardless of weather conditions, it's tricky, right? Small scale farmer, not really part of a large corporation who produces food. Yes, so you're probably not producing food for a large corporation, although in some cases, large corporations such as like even Unilever, they will recruit smallholders to produce food for them, right? But for the most part, you're probably doing farming on a subsistence scale. If you're a smallholder, you probably use very simple, outdated practices, very simple technologies, very simple inputs such as seeds, fertilizers. You probably don't use fertilizer. You probably don't use irrigation. You don't have any sort of machinery. Your productivity is probably quite low. You don't hire anybody, so you don't or if you do, you're probably recruiting your family to do labor on the farm. Those farms tend to be also very labor intensive. Um, and and in many cases, the family members have to do a lot of different things on the farm. Okay. And the second question is, what is a subsistence farmer? I think we all already know what that means. So subsistence farmer is somebody who grows just enough food they can survive on, right? All right. So the follow-on question is, what are food crops? Because when we talk about what it is that smallholders produce, they produce either food crops or cash crops. So yeah, when I mention food crops, can you name a number of food crops that come to mind? Yeah, everybody's saying wheat, corn, soy, rice. Yep. Yep. Exactly. So, it's typically tubers or root vegetables or grains that we're familiar with, right? And here I give you the example of cassava and wheat. So I guess you have the slide so you can see those. But in any case, cassava is a root vegetable that's very common in Southeast Asia and in Africa. And obviously you're familiar with wheat and rice as foods that people grow. Now, on the cash crop side of things, um, give me some examples of crops that one would grow as a cash crop. Cashews, yes. Cotton. I wouldn't consider corn to be a cash crop because it's mostly consumed either by people or by livestock. Jute, yes. Coffee, yep, absolutely. So, things like sugarcane, things like cotton, things like tea. I give the example of vanilla here. Marijuana, true. Um, so, these are crops that one typically grows um, in order to sell, to make income. And somebody said coca and palm oil. Yes, these are also cash crops. So if it's a crop that you're growing solely to sell it, that's what it is. And they typically they bring in quite a few dollars. Now the key thing about cash crops is that their prices it's kind of similar for food crops, but for cash crops especially, for prices fluctuate a lot, right? And I give the example of vanilla here because look at vanilla, right? From the 1990s to the year 2000, it was less than $20 per 20 euros per kilo, and then it grows tenfolds to 200, and then crashes back down in 2005, and then sometime around 2014 it just goes bananas, and it goes parabolic to 500. If any of you know the reason for that, and if you can write it in chat, I'll be very impressed, because there's an interesting story behind it. But in any case, the reason why I mentioned food crops and cash crops is because as a farmer, you have to make very difficult decisions at the beginning of each season, to decide, how much of my crop is going to be a food crop and how much is going to be a cash crop. Because when we're talking about food crops, in a lot of cases, farmers farmers don't know how good the season is going to be, so they usually lean too hard towards food crops. And what ends up happening is that typically, they'll sow their seeds sometime in around May, and I'm talking about the Indian subcontinent in general. So they'll sow the seeds around May. They'll get a lot of rain till September, and in October they will harvest their crops, and then they'll store it. And they're gonna start eating whatever they have from October till like maybe January, and then from January till May, or sometimes from February till May, they typically have very little food left. And these are called the lean months or the hunger months. You know, these are months when farmers literally go hungry, and they either have to starve until and beg until the rainy season arrives, or um, they can go to the city and do manual labor in the city. And they're often, you know, as farmers, they are not looked upon very highly. They're taken advantage of and so on. And it separates families. So women will stay on the land and the men will go to the city. This, you know, the sons might stay, some of them might go. So it devastates families, right? I don't actually know the difference between French vanilla and vanilla. I don't actually know. But I think there's the vanilla crop. I don't think there's a crop called French vanilla. All right. In aquaculture, there's a very similar distinction between cash crops and food crops, right? So the food crops would be considered low value species. I'm not going to ask you to guess those because it'll be a bit difficult. Low value species are typically things like kelp or seaweed, right? So these are typically grown to be consumed. Same thing with catfish or tilapia, which can be grown. Like you can see how crazily tight those fish are packed. And same thing with pangus, which is also a different kind of catfish. So catfish, carp, and kelp are three kinds of fish or aquatic species that are very commonly grown as low value species. High value species are typically things like, you'd probably guess this one, they'd be things like shrimp. So this is a massive shrimp farming operation, and salmon. And the thing about salmon that you should know is that if you've had salmon recently, either on sushi or as a fillet, like I said, I would bet my bottom dollar that it was probably farmed, because, you know, farming has long overtaken wild capture of salmon. So, yes, French vanilla is an ice cream, not a crop. All right. So now that we've covered who the smallholders are, what kind of crops they grow, where exactly do they live? Now this map here, and I'm going to give you a second to look at it. This map here shows you the distribution of farms by size. So green and blue means large or very large. Yellow and red means small or very small, right? So I'll give you a second to look at it and peruse it. All right. So I think you've probably all noticed that, you know, the pattern here is that in Western Europe, in North America, and in Brazil and parts of Argentina, most farms are quite large, right? Whereas, you know, the smallholders are mainly concentrated in West Africa, East Africa, and the Indian subcontinent, as well as Eastern China, right? So, you know, this information is very important because, you know, as we'll discuss in a second, you know, we need to know where the farmers are, because these are the people we're trying to help. And oftentimes this is very hard to ascertain where they are in the world. Okay. I have a question here. What happens if a high value species or if a cash crop is not in demand? Is it still high value? So Bisha, this is a very good question. And this is why it's so hard being a farmer, because you never know if the price of that thing is going to be what you expect it to be, right? You might plant your vanilla bean trees, or you might pollinate them, which is a very difficult process, and you go through that whole, you know, endeavor knowing that, you know, that you're going to be able to sell it for $200 a kilo, but you end up having to sell it for 50. A cash crop is always going to be a cash crop because you're going to sell it. Most people, most smallholder farmers are not going to consume vanilla. So it's always, it's a tough call for them. Sometimes they have to, um, sometimes they have to just take that loss and hope that it doesn't devastate them in the long run. So that's why so many of them lean towards food crops. All right. So, you know, again, I showed you this map. I really love this map. And the one thing it made me wonder is how the hell were they able to tell this? Because this is dots. These are like individual farms. So it got me wondering how that was possible, because there's a lot of technology involved in estimating those figures of you know, where the smallholders are, where the farms are. And it turns out that there's two ways you can do it, right? There's the high-tech way, which involves delineating farm fields using satellite images. So basically you take satellite images of farmlands or aerial images using airplanes, and use a combination of image processing and machine learning to just draw the lines, the edges of where the farms are, in order to sort of guesstimate what the size of that farm is. And then you do a count based on that, which is really fascinating. I mean, this is actual applied high-tech research for the ECEs and the computer scientists here. Right? This is where your knowledge may be applied and may be extremely valuable. Right? The other way is a bit more low-tech, which involves looking at agricultural surveys. Rwanda has a really good one. Kenya has a really good one. You know, they have it at the subnational level, so you have exact numbers and they're updated quite frequently. You know, so these are two ways that it can be done. The last one, which I learned about, I think 2 years ago, was this really cool crowdsourcing method. So you can volunteer just like as you would on Wikipedia. You as a well-wisher who wants to help scientists and researchers understand the farming distribution in low-income countries, you basically can open this dashboard and it shows you a picture of a satellite image of a bunch of farms, and then you manually sort of draw the borders of a farm, and you keep doing that, and it processes the farm, and then that feeds into a machine learning algorithm that can do basically this, right? And this, obviously, crowdsourced data is never always reliable, so it's validated by experts every once in a while, so they do statistical spot checks to see if the person who's doing this knows what they're doing, or if they don't, then they just discard their contribution. Any questions? I'm getting so many emails these days. I'm sure you are as well. It's like it's every 10 minutes there's a new update. You can't help but check because you're like, oh, what happened now? All right, moving on. All right, so you know, I think you know we've already sort of answered this question, but why focus on smallholder agriculture and specifically subsistence agriculture? Well, I mean, for one, if you look at the numbers of the billion or so people who are living below the poverty line, the vast majority of them live in rural areas. And you know, if you look at Africa, or if you look at parts of the Indian subcontinent, the vast majority of rural dwellers are operating smallholder farms, right? And you know, those people, you know, those people collectively, those smallholder farmers, they manage, you know, well over 80% of the world's estimated 500 million small farms, and they provide a majority of the food that is consumed in most low-income countries. So as a result, you know, smallholders contribute massively to poverty reduction and food security. And if you can help them get over a hump, help them get over a bad season, provide them with the right technologies to empower them, it can have an immense impact on lifting people out of poverty, because they really are at the base of the pyramid. And at the same time, they do the world an incredible favor, right? And the sad reality is that you know, a lot of those poorest of the poor, you know, more than 50% of them are women, right? This is something that comes as a surprise to a lot of people, that 60% of farmers in low-income countries are women, because what ends up happening oftentimes is that the man and the sons will travel to the city to do manual labor, while the women take care of the young children and do the farming. It's incredibly backbreaking work. And so, you know, as a result, a lot of people, you know, say that women are the backbone of those rural societies. And you know, I won't go again into why a lot of what you should focus specifically on women. But in case you forgot, you know, women are the ones that for one, are more financially responsible. They make decisions on fertility. Investing in women's resources tends to have a huge impact on uptake of agricultural technologies, on the health of the household, on the health of children, and so on and so forth. Okay. And the other thing is that, you know, if you look at countries like Tanzania or Rwanda or Nepal, in countries like this, agriculture makes up between 2/3 and 80% of the country's entire GDP, and they employ, you know, at least 2/3 of the population. So, you know, a huge part of their economy depends on agriculture. And you know, I don't like quotes, but you know, I'll stick to this one because Gunnar Myrdal is an economist who said way back in the 70s that it is in the agricultural sector that the battle for economic development will be won or lost. The reason why I include this quote is because he was so far ahead of his time. You know, back in the 1960s and 70s, the paradigm in international development was, you know, let's just build highways and bridges, and you know, and for the really poor people, we'll just send them bags of rice, right? You know, we're always, and it still kind of endures, we're always concerned about the availability of food, you know, and we think of aid as bags of rice being delivered to poor people. But really, you know, if you really want to have an impact on people living in poverty, try to focus on how you can bolster their agricultural practices. All right, I'm doing surprisingly bad on time, so I would typically open this up for questions, but I'm gonna go straight into what the challenges are for smallholder farmers, because I really want to do a case study at the end, because I think you'll really like it. All right, so what challenges do smallholder farmers face in low-income countries? Well, as it turns out, tons of problems. The first one is one that you probably don't necessarily think too much about, which is land fragmentation. What does that mean? Well, it means that, you know, let's say, you know, Ubisha owns this little parcel of land, and then this little parcel, and then this one here, right? And then Ben owns this one, and Jackie owns this one over there, and this one here, right? And the effect this has is that it makes it very difficult for you to manage your farm, right? If you buy a tractor, you know, a tractor might be justified for these two parcels side by side, but having a parcel here and a parcel here means that you have to drive with your tractor over somebody else's land to get to your plot. That doesn't usually happen. And the reason why land is so fragmented in a lot of countries is because of colonization, right? So colonization created these imbalances in land ownership, and then after a lot of countries became independent, there's a lot of chaos. You know, in a lot of places they don't really have enforceable contracts on land. So, you know, people who basically were living on this land after decolonization, they just kept their right to that land. And if they had family who were living on or working on this plot, they get to keep that land. So land was, as a result, extremely fragmented. And you know, there's a lot of ways you can try to solve this. You can create contracts that consolidate land, but you know, it may be the case that, you know, if you have a plot here and a plot here, you know, this sort of hedges your risk against pests or something. So, in some cases, they don't necessarily want to consolidate their land. Why can't they buy tractor together to increase their yields? Yes, so cooperatives do that in a lot of countries. The problem is that cooperatives have a bad reputation, have developed a bad reputation over the years in a lot of places, and it's a long story why this has happened. But typically, in a well-functioning cooperative, yes, you would band together with your neighboring farms, and you would invest in a common irrigation system and a common tractor, and you would share it, and everybody would be treated fairly. But unfortunately, in countries where there might not be as much social cohesion, in countries like Rwanda, which are still healing from the scars of a horrible civil war, there's a lot of inequality. And so you might feel like you might be pitching in for a tractor, but you don't get it as much as you expected or as much as you feel is fair. So distrust in cooperatives definitely makes the challenge of sharing land even harder. Another problem is over-reliance on monsoon. So as I mentioned, specifically in the Indian subcontinent, people rely on rainfall to irrigate their crops, and they don't have irrigation systems. So, if you're planting rice and the monsoon arrives way too late, but you've already put your seeds in the ground, there's a chance that those seeds might get eaten by birds. There's a chance that they might not germinate well, and your crop yields are going to be bad at the end of the season. And if the monsoon arrives too early, then that means that there's at the tail end of the season, your crops are going to be growing in complete dryness, which again limits the yields that you're going to get. Poor road infrastructure. So this one I think is self-explanatory. If you're a farm owner, you need to go buy seeds or you need to sell your crops. If this is the kind of environment you have to cross, it can have a huge impact on the kinds of markets that you have access to. So you get shut out of markets with lucrative prices, right? Soil degradation is a huge one. One big problem is that a lot of smallholder farmers don't have access to a variety of seeds. And oftentimes what they'll do is they'll grow the same damn crop over and over and over again in the same plot of land. And their neighbors will do the same thing, and their neighbors will do the same thing. So you'll have these massive plantations of the same crop being grown. And this is called monocropping, just growing one crop. And it's bad for the soil. It's horrible for the soil because it sucks out the same nutrients every time. And when the crops die, they give when the chaff, the remaining crop that you don't harvest, degrades back into the soil, it will give a certain amount of nutrients back, but not in a balanced way. Different chaff from different crops give different nutrients back into the soil. So what you want to do is you want to rotate your crops, or you want to have different crops growing on the same plot of land, because number one, you diversify, and number two, you give back nutrients to the soil. So monocropping destroys the soil in a lot of cases. And things like overuse of fertilizer or pesticide also have a huge effect on soil degradation. Other challenges, we talked about slash and burn when we were talking about palm oil. So, palm oil is a monocrop, so it destroys the soil quality after a while. So, it becomes impossible to grow palm oil again after you've planted it on a plot. So what people typically do is they'll just, they're usually living in wooded areas and forests. They'll just cut down a forest and then they'll just set it on fire to clear the land so that they can grow more crops in that section of forest. And obviously, deforestation is bad for a lot of reasons. It results in the loss of habitat, increases air pollution, results in accidental fires, and results in soil erosion. Right, a lot of these big trees in the forest, they stop mudslides and rainfall from reaching human settlements. And as you keep cutting those, you're stopping the only barrier to those massive rainfall events. And actually, in India, in around the month of, I think around the month of November, I might be wrong, they have a huge black cloud that streaks across the sky. Like in Delhi, it's pretty horrific. Usually people just stay at home. And it happens because of this slash and burn issue. And also because, farmers burn the chaff on their farm in order to get rid of it. So anyway, just something to consider the effects of that. And ultimately, people will blame the farmers. People will blame the farmers themselves for creating this air pollution rather than, try to understand where it is that they're coming from, and rather than push the government to provide them with alternatives. I mean, one of the big problems for farmers is that in India, they force them to use a particular kind of seed, and that seed produces a crop that has a very thick brush that has to be burned. It can't just be removed from the ground, and they don't give them options to burn that chaff in a way that can be used to generate heat or electricity. Wasn't it in Thailand? It happens pretty much everywhere in low-income countries. So it happens in India, happens in Thailand, happens in the Middle East, and in sub-Saharan Africa. It's quite common. Why do they force them to use that seed? To create uniformity. It's we're going to talk about the problem of counterfeit seeds. It's a huge problem in India and in Nepal, where bad actors will sell counterfeit seeds to farmers, and so the government basically steps in and says these are the only types of seeds that you're allowed to sell, and that's a way of protecting the smallholders. Yeah, it's messed up. Other challenges for smallholders is inefficient markets. In a lot of cases, farmers don't know where the best prices are. They don't know what prices they should sell at. They take just a random stab at the dark. And, unfortunately, again, if you're a woman or if you're from a lower caste, you're going to be forced to sell at a lower price because some people might not even look your way. Price volatility. So this one is self-explanatory. Very hard for you to plan if the prices fluctuate too much year by year. And the last one is access to credit. We talked about this. If you can't access credit, then you can't invest in technologies to improve your farming practices. And looking at sort of the bigger picture, in a lot of cases, there's a very strong link between conflict and food insecurity. This is especially the case in places like the Congo, where you have conflicts that create food shortages. Those food shortages exacerbate conflict between people. So it's a never-ending cycle of conflict. Even though food availability needs to double by 2050, agricultural productivity has been stagnating for a while for those reasons that we discussed, right? Which really lends credence to why we're doing this lecture, right? And again, the low uptake of this technology is problematic. Just to give you some examples of what those technologies are, there's high yielding varieties of seeds. So there are really good types of seeds out there that can produce high yields, but also be resistant to pests and to low moisture. So those are a great technology that exists that are not readily taken up by farmers, and we're going to talk about why. Irrigation systems are not too widely used amongst farmers. Post-harvest processing technologies, so methods to store your harvest afterwards so it doesn't spoil, and then crop insurance. So we're going to talk about most of these after our break, which is going to be in a couple of minutes. But we're going to talk about each one of those technologies and what it is that stops people from using them, farmers from using them. And as always, we will use this guy as our guiding light, the agricultural value chain, right? If there's one thing you're going to take out of this course is the importance of understanding value chains, right? So in an agricultural value chain, I think it's quite easy to understand. It's self-explanatory. The first thing you need to do is plan, right? So, Verlin has a farm. She needs to plan, okay, the price of cotton is this much. The price of tomato last year was that much. So I'm going to split my crop between these two. I'm going to buy my crops. I'm going to buy my seeds from this person, and I'm going to have this person as a backup. And, in case the monsoon arrives early, I'm going to do this. In case the monsoon arrives late, I'm going to do that. So this is what planning entails. Then she's going to go out and buy her inputs. Inputs include seeds. They may include, fertilizer or pesticide. But again, if she's a smallholder, she probably can only afford the seeds and nothing else. And then she's going to watch her crops grow. And as they grow, she needs to remove the weeds. She needs to monitor the crops to make sure there's no pests. She needs to undertake some steps to make sure that her crops grow. And at the end of the season, she needs to harvest her crops and she needs to store them properly. And when you're storing your crops, you need to make sure you do it in a way that doesn't spoil it. And I'm gonna give you an example of that. After that, you're gonna have to do some processing steps. So this is where you're really adding value. So if you're producing rice, for example, if you're producing, let's say, I'm drawing a blank on this. If you're producing oranges, for example, processing them into orange juice is a much higher value product than just raw oranges. And you have to transport them and take them to a market where you can actually sell your crops. Okay, so this is the ag value chain, agricultural value chain. And like any value chain, it has, for smallholders, it's extremely restricted, right? Smallholders might not be literate, so they don't know how to plan properly their farming practices. They might not be able to buy their inputs. They might not know the value of those inputs. They might not understand exactly what sorts of steps they need to take during farming, and so on and so forth, right? So I'm not going to go over each one of those, but those are some ideas. Those are some prescriptions for some of those problems and how you can solve them. So for planning, if you're an engineer, maybe help farmers plan what and when to plant. So, farmers don't necessarily know the prices of crops. So there are apps being developed to help farmers understand the prices of crops, that connect them with prices in different markets. For inputs, how can you reduce the incidence of counterfeit seeds, or increase access to quality inputs like fertilizers, for on-farm production, providing extension services to farmers. So I gave you the example of Digital Greens, which enables farmers to share knowledge about technologies and practices, and on the list goes. I highly recommend you take a look at this. It's very easy to understand. And, it will give you sort of an idea of where the pain points are and what one can do to help farmers with their difficulties in farming. I'm gonna blitz through this one because I'm not focusing too much on aquaculture, but the aquaculture value chain, you've seen it with the crab value chain on the midterms. So it consists of pond preparation, so draining the pond, putting lime at the bottom in order to neutralize any acidic byproducts from the benthic bacteria at the bottom, compacting soil to make sure your water doesn't drain. So you basically create your pond, you add your fingerlings, your little fish, you add manure as food for the fish, you add nets, and then you produce your fish. So you need to aerate them, to harvest them, and then put them in ice, transport them to the market. So we're not going to focus too much on this. So with that, I'm going to give you, let's say, a 9-minute break. And feel free to ask me questions through this break. and feel free to stand up and stretch a little bit as well. And when we come back, I'm going to talk about 3 focus topics of technologies in the agriculture value chain. So let's reconvene in 9 minutes at 1:20. Phil asks, what is the source of the ag value chain? Can you elaborate on the question a bit? Where can I find more information about each of those solutions? So interestingly, I got this value chain right here from an event that I had attended with USAID. So they were doing a lot of work with smallholders in Nepal. So I can actually share the document with everybody in class that they put together on the research they did with smallholders there. It's actually very valuable, and I have 2 more slides in at the end of the lecture with that research. Liam asks, will the final exam be weighted differently now that it will likely be taking place online? Probably not. There's a process that I would have to go through to get that approved, and I don't really see a reason why I would reweight it. But again, I mean, I don't want anybody to worry too much about the grade and the course, especially under these conditions. I'm understanding of the stress you're under, and so is the university. So yeah, I've never done an exam of that's weighted 40% online before, so Trust me, this is an experimental process for you, me, and for all of your other professors and instructors. So um, have faith that we are understanding of the situation that you're in. Verlin asks, will the exam be harder? Um, I honestly don't know because it'll be different. It'll have to reflect the fact that it's online. Um, I will very likely, send you an email with the exam or post up the exam on Quarkus, and then give you maybe 3 hours rather than 2.5 to get it done, and scan it and send it back. I know not all of you have scanners, so maybe I'll just have you type up your answers instead. But then again, if a lot of you are out of Canada and in places where the time zone doesn't work particularly well for you, then I'm gonna have to think of alternatives. I really hope that none of you are out of Canada. Is anybody out of Canada in the comments? I know Bettine had emailed me saying that he's going to Turkey. That he's going to Turkey when? Today. So I really hope he didn't end up going, because I'm not sure. Unless he's a Canadian citizen, he can't really come back. But even if he is, I don't even know if it's possible to catch flights back. So yeah, no, I don't want you to be anxious about grades. It's, if you're mentally on in class, whether it's online or during class, you will do fine. Yeah, I'm not gonna lie. I do feel. Let me weigh this to say it properly. Um, yeah, I graduated during a recession, and shit ain't easy when you graduate in conditions like that. And I'm not trying to scare you, but I want you all to be prepared, and I'm sure you're already thinking about that. But graduating into a pandemic is probably, it's not going to be easy. And so, if nothing else, I know that it might take a month or two for you to start seeing job postings and to be able to be competitive for those postings. So have some backup, something that you want to do over the summer, ideally something that doesn't require too much in-person interaction. Typically, I tell people to either travel and see the world, or if they have the money, or go to networking events. But neither of those are options right now. E-commerce startup, yeah. Hey, you know what? One thing that I've been thinking about, and I don't have the programming skills for it, but I've been thinking about all the local businesses, the small businesses around me, and they're gonna suffer if there's an actual lockdown. And so I was thinking, if there's an app that allows you to give them money now and then in exchange get a coupon, that allows you to use it once the lockdown is lifted. That way you sort of tide them over. Could be something that's interesting. So, if anybody comes up with that idea, ideally it wouldn't be a money-making enterprise. It would just, skim like maybe 1 or 2% just to keep the lights on. But just a thought. Buying gift cards at restaurants, yeah. Support your local businesses. They're gonna have a hard time. A lot of people are gonna have a hard time, myself included. And just you gotta stick to each other, and that's how we get through this, is by looking out for one another. And if you look at how West Africa got over its pandemic, a lot of it had to do with community action and people looking out for each other and not profiteering off of each other by selling toilet paper and Lysol wipes for like 300% markup. But that's a discussion. That's a rant for another day. All right, so back to the topic at hand. So I'm going to focus on a few interesting points in the. I'm going to focus on a few interesting points in the value chain, and talk about a few technologies, appropriate technologies that have emerged that offer promise for farmers to improve their resiliency. So the first one I want to focus on is irrigation, right? Specifically, it applies to the on-farm production stage. And let's talk about that a little bit. So, this is a silly question. How do smallholder farmers typically introduce water to their crops and LICs? I already said that multiple times. It's through rain, right? So they have to wait for the monsoon to come in to actually irrigate their crops. If they are lucky, and why is irrigation important? This one is also quite self-explanatory, but perhaps something that I should spell out. Irrigation benefits smallholders by increasing their productivity, by improving their yields. Yields basically means how many kilograms of produce per hectare of land they have. It lowers the risk of crop failure. It keeps away diseases. It doesn't really keep away pests, but it reduces crop failure due to diseases. It increases employment on the farm because it enables year-round farming. It also enables smallholders to more easily adopt diversified cropping patterns, so they don't have to monocrop, and to switch from low value sort of subsistence crops to more higher value cash crops. So that's a big part of the reason of why irrigation is so important. Now, for those who have the blessing of a water source nearby, they can irrigate their crops in one of two ways. They can either dig a canal and then open the floodgates, and then they would just flood their crops like this, and this is how rice is essentially farmed. Or they can fill a bucket and then irrigate it the old-fashioned way, the same way you would on your garden. Now, this is quite rare because it's rarely the case that you have a water body nearby. In any case, if you have a water body nearby, you're probably going to do this instead. And the problem with flood irrigation is that it wastes so much water. And actually, let me take a pause for a second. It wastes a lot of water, and it results in an issue called waterlogging, where there's too much water in the soil and it stops the roots of the plants from taking up nutrients from the soil, right? But more than anything, it's just a massive waste of water. And this is where drip irrigation comes in. Now, the way drip irrigation works is quite simple. You fill a tank with water. It doesn't have to be a very big tank, right? And then you elevate it a little bit, and then you run a water line down to the crops, and then that main line separates into a bunch of laterals. Each one of those laterals, you just basically poke a hole in it or put something called an emitter. It's just basically something that drips like little tiny drips of water, one every minute or so, and it drips it directly where the roots are of the plants. It's really cool, right? And you can fit a strainer in here so that you can fill dirty water in here and it will get strained and filtered. And you can even add fertilizer. So you're adding water and fertilizer to the roots of the plants. That's called fertigation, like irrigation and fertilization, fertigation. And the reason why this is great is because with just a small amount of water, you can grow crops at any time of year. So it enables farmers to grow off-season fruits and vegetables. A tomato, for example, in Nepal costs 4 times as much in the dry season as it does in the wet season. So, something that would be normally a food crop could all of a sudden become a cash crop because it's grown in the off season. And you do that by just having a small system like this, right? And the cool thing about drip irrigation as well is that it's very easily divisible, meaning that you can fit it on small farms or big farms, right? You can come up with your own little wacky cool contraptions, like check out this farm here where it's just $50 for the whole farm, for the whole garden, and it's made of a bunch of water bottles with water and a bit of fertilizer, and you can't see it, but there's a few little silicone tubes that run directly to the roots of each plant. And it's a very cheap and a very effective way of metering out water to where it needs to go. And it has an incredibly high payback. If you can grow these off-season vegetables, you can double or sometimes triple your income in one season, right? And it obviously builds resiliency against climate change. So you're not too reliant on those irregular monsoon patterns, right? And again, the focus here is on women because in the off season, usually men would go to the city to earn cash on the side to do manual labor. So the women who are working on the farm can usually grow crops on their own plot of land. And women, again, there's study after study that proves that they manage their the household's income and food supplies typically quite well. So enabling them to do that is great. Yuanfan asks why does drip irrigation enable the growing of off-season fruits? Okay, so in the off season, which is the dry season, there's no water. There's not enough water to grow vegetables and fruits. Vegetables and fruits are pretty thirsty, right? So they're typically grown in the wet season when the rain is coming down every day. So yeah, in the dry season, if you can just store a bit of water from what little rain comes in the dry season, or if you even buy that water, you can, and just drip it around, you can ostensibly stretch that small amount of water to be able to grow enough of a strawberry or a tomato harvest to justify the cost of the system. Let me know if that answered your question. If not, I can explain it again. Just give you a second, actually. Off season is dry season, correct? Yeah. All right. Another great technology, another appropriate technology that has emerged in the area of irrigation is the treadle pump. It's really cool. Basically, a lot of farms have groundwater, and to get that groundwater, you have to drill a little well, and in the worst case scenario, you lower a bucket in there, and then you raise it, and then you irrigate, and then you keep doing that over and over and over again. So this was something that came out of research by the Lutheran World Federation in Bangladesh. They came up with this design. It's basically the treadle pump is basically like a Stairmaster. Like when you go to the gym, you use the Stairmaster, and each time you pull and push on this pulley, it sucks water out of the ground and then pushes it onto your garden. So it's a little exercise that helps you irrigate a fairly large plot of land with minimal physical effort. And you can make it so that it costs $20, can be made of bamboo shoots, or you can make it out of proper metal, which can be like $100 or so. But you know, it's an absolutely transformative technology. Um, and you know, it can increase a farmer's income by up to 6 times, according to a study from Niger. And one report by the Institute for Water Management Innovation called it one of the most powerful and best targeted poverty alleviation interventions the world has seen. Just a pretty bold and a pretty audacious claim to make, but it's not hard to see why. It's something that's so easy to build, so easy to maintain, costs very little, and really can help enable irrigation for a wide swath of smallholder farmers. And the cool thing is that you can combine a treadle pump with a drip irrigation system. So you attach like a little hose to a water body or to the ground, to groundwater, and you can pump water into a drum, and then you can drip irrigate your crops, and that way you can conserve your groundwater, because here they're basically pumping it to flood their farm, whereas in this case they're pumping it just to be able to drip irrigate their crop. Right. So really, really cool, really interesting technologies that are having a huge impact in some countries. Now, if you're blessed with wind, you can actually have the wind do the work for you. And basically, you know, in this case, you're basically fitting a wind turbine onto a rope and washer pump. Now, a rope and washer pump consists of 2 pulleys, one at the top, one at the bottom in the water, in the groundwater. And then you have a rope that goes around it, and along that rope you have little bungs here, and then you have a riser pipe on this side. So as the rope spins, the bungs go down, they pick up a column of water, and then they push it through the riser pipe up to the top. So instead of a pulley, you have your wind turbine. So as this guy spins, it keeps moving those bungs up, and then it drives water up from the ground. And you want to know what's really cool? A bunch of U of T students affiliated with CGen during their capstone project actually went to Nicaragua, built this system, and it's actually providing water for that community that can be used for consumption or drip irrigation. So yeah, that gives you a sample of the types of projects that we do. Sonia wants to start her own spice garden. Yeah, I mean, it's really fulfilling. I grew up on a farm, and you know, the first time you actually grow something and you consume it, first of all, it tastes a lot better when you actually grew it yourself. And you know, it's you know, it's like taking care of a pet or something. And it's a very fulfilling experience. So if any of you are interested in, I mean, I keep telling you about how highly impactful agriculture is, and you know, how high the ceiling is for innovation and engineering in agriculture. You know, that's true. That comes from a real place. So for those of you who are really curious about those careers, you know, a good place to start would be to actually try growing your own little plant, understanding how difficult it is to get it right. And then you'll realize that what you know about engineering can really help you make this process a lot more efficient, a lot more effective. All right. Feel free to jump in with any questions, by the way. Moving on, focus topic number 2, grain processing. So I'm going to shift my focus now from on-farm production to post-harvest processing. And for this part, I'm going to focus on a grain called fonio, which is grown in the Senegal. Oops. A grain called fonio, which is grown in the Senegal. Now, fonio is a crop. It's an incredible crop. It can grow in very dry climates. It's very hardy, and it assures the livelihood of a lot of people in West Africa, in Senegal, Sierra Leone, Guinea, and so on. And so you know, the way it works is it's very similar to rice. You produce a paddy fonio, you hull it, you separate the husk from the fonio. So this is like brown rice. And then if you grind it down and wash it, you can produce white fonio. So that's like white rice. So it's very similar to rice. It's a typical grain. Now, what we know is that, it can provide an excellent source of food and income security, and it can be exported. But the problem is that it's just not competitive with other cereals, right? It's twice the price of rice. So it's sort of a niche, a niche crop that hasn't been grown at a wide enough scale to be competitive with rice, right? And the problem has to do with the fact that, there's no technologies out there that are enabling the farmers to actually process the fonio to make it into a high value product. So, if you look at how farmers do it, they grow the fonio, then they have to thresh it. Basically, this involves hitting the crop with sticks to separate the patty from the stalk, right? And you have to pick up those patty fonio, you have to winnow them by hand, and you have to hull them and whiten them using a massive Q-tip looking grinding mechanism. Like it's like a big mortar and pestle. And then you have to wash it in order to separate the bran from the fonio. It's pretty, it takes a lot of effort, and people will do that just to feed themselves. But, if they have to sell it, some technology, some innovation is necessary to automate this a little bit to be able to make it competitive. So this is where the French aid agency came in. They funded a research group, an engineering research group, to go work with that Senegalese community to design with them a low-cost fonio dehuller. So this is a machine that can just dehull the fonio right there. You just put it into the hopper, and it separates the hulls from the bran, and then the actual fonio comes out here. The whitened fonio comes out here, and then and then to wash it, rather than wash it like this using a sieve, they designed a rotating sieve where you just fill the fonio in the middle, and then you rotate this drum. There's like a little bit of water here that removes the whoops. Making a lot of mistakes now. That removes the bran from the whitened fonio completely. Just completely whitens the fonio. And then you can take this wet fonio, you could put it in a greenhouse solar dryer, and you can produce fonio on a very large scale. And they didn't stop there. They helped connect the farmers with packaging companies that design cool looking packaging for them. And, now some fonio is exported to Europe and the US as being marketed as, wow, a lot of mistakes. It's being marketed as a super grain. And so, it sells for a lot of money. Yeah, so it's an example of technologies that are able to build up and amplify the agricultural value chain for a particular crop. I'll give you a minute if you have any questions, because I think I went on a long tear now. This isn't weird anymore. In the beginning, it was kind of weird, but I'm starting to get used to it now. Okay, but before I move on to the last case study, I want to talk about this part here, the post-harvest processing part of it, or sorry, rather, I want to talk about storage, because that's a huge problem. A lot of crops are wasted because they are damaged in storage, and one example of that is potatoes. So a colleague of mine, she worked with an engineer in India who was trying to figure out how to reduce the spoilage of potatoes. Because you see, the way potatoes, and for that matter, cucumbers and other crops, other vegetables are farmed, you lay them down in a little hut and you make a mound out of them. And obviously, after some time, you've probably seen this at home, after some time, the stuff at the bottom starts to decompose, right? So his solution was so simple. It was just running a bunch of PVC pipes with holes drilled in them into the hut, and then they just did, the business as usual. They would just throw the potatoes, and they're able to reduce the spoilage by some 30% just because of the air being pushed in these pipes. I think they painted them black to drive the airflow in them a little bit better. So, that was a very successful method of trying to reduce post-harvest spoilage in potato farming. I don't know the exact number. I don't want to lead you astray, but I think between 20 and 40% of all food that is produced on farms is wasted before it even gets to the truck. So before you even get to transportation, up to 40% of the crop is damaged in storage and in processing, either because it's eaten by pests, or because it just spoils, or because there's no refrigeration on site. So these are a lot of the problems that exist. All right, last focus topic of the day, and then we're gonna do a really cool case study together. I don't know how it's gonna work out, but I have an idea of how we can make it work. But before we do that, last focus topic of the day, weather index insurance. So weather index insurance fits under the planning, right? As a farmer, you may need to insure yourself against catastrophic losses, right? And wait, I'm spoiling the next slide. All right. Okay. So to give you an understanding of why I picked weather index insurance, consider this. Consider you may have designed a really cool solar irrigation system, right? It's something that is valuable for farmers, and it's something that they said that they would like, but it's expensive, obviously. And in a lot of low-income countries, and I'm thinking specifically about Nepal because I had met somebody there who manufactured and sold solar irrigation pumps. There's very little access to credit, so it's very hard to be able to afford these things. It's very hard to be able to get your hand on credit to buy these things. Consumer protection laws are very weak in low-income countries like Nepal, meaning that if a farmer buys this pump from you, they don't know that you're going to honor your warranty if it breaks down after a month. And as a result of these problems, customers, specifically farmers, are very risk averse to these large investments, right? Especially when it's something like really snazzy and new and cool, like solar powered pumps, right? So that's one huge barrier to uptake of new technologies. So to dig into this a bit more, let's take the case study of Joseph, a corn farmer in Kenya. Now, because Joseph doesn't have insurance, because he doesn't have access to easy insurance, he doesn't necessarily plant very high value crops. He plants just corn. And he doesn't invest in any technologies in his farm because he's worried that if he has a catastrophic year, that's it. He's going to lose everything, right? So he can't afford to take any risk by investing in any new technologies, right? Now, Joseph can get traditional insurance, crop insurance. We call that indemnity-based insurance. That's the same insurance you have that's the standard insurance that everybody has. The way it works is Joseph would come to me. I have my own insurance company. We'll call it Ahmed Insurance Group, AIG. Okay. Now, my company is going to send somebody, an appraiser, to go to Joseph's farm, and they're going to estimate Joseph's crop value and his potential loss due to a drought, because that's the most common reason for crop loss. This is obviously an actuarial process that requires somebody who's quite well trained, and it's expensive to send somebody to do this appraisal. And it obviously doesn't make sense to do that with smallholder farmers. Now, if AIG agrees to insure Joseph, if my company agrees to insure Joseph, we're going to make him pay a monthly premium. If his crop gets damaged, he's going to give me a call, and I'm going to send the same appraiser back, and he's going to make a thorough assessment, and then they're going to pay out if the terms of the insurance are agreed upon, or if they've actually happened. Okay. Now, why do you think this indemnity-based insurance might be bad, either for the farmer or the insurer? Why would Joseph not want to take me up on my offer, and why would I not want to insure Joseph under these terms? I give you 2 minutes to come up with an answer, and then we'll see. All right, I'm getting a few answers here. So Liam says the farmers might not always pay their premiums on time or at all. Absolutely. If you have a corrupt company, they may not pay even if the situation does occur, correct? For a smallholder, you might be charging him a high premium he can't afford. Absolutely. It's hard to get payback because it's an expensive evaluation process, high risk factors. Exactly. The margins are already low and they can't afford to pay the premium. Exactly. So you guys hit hit the nail on the head. So, the common thread here is that, there is no trust. The farmer doesn't trust that the insurer will pay on time, and the insurer doesn't necessarily trust that the farmer will pay their premiums, right? Um, the other issue is that, for the farmer, the payout typically arrives pretty late because they have to send an appraiser. And usually when there's a drought, it affects many farmers. So it takes a while to get through the backlog. And so, farmers need their payout early, because if they don't get their payout early, they don't buy their inputs for the following year. And that could be devastating, right? And, one other thing that could be a problem is the moral hazard problem, because, in this case, if farmers feel that they are covered by insurance, does that mean that they won't take as much care of their farm? Does that mean that they would, maybe notice that a bunch of pests are on their farm, and maybe they don't spend money on pesticide because they feel like they could get an insurance payout? So, there is this problem of moral hazard, and as Ahmed surmised, the margins are pretty low, and as I think Calvin or somebody else said, it's a very expensive process to send out appraisers every time you want to assess or a farm or make a payout. And Liam also added the point: no institutions are in place to hold either side accountable. Exactly, there's no proper consumer protection that exists. And Patrick points out, does the insurance company have a clear standard of a natural hazard? That's the thing. Each company drafts its own requirements of what a drought is. So if we don't agree about what a drought is, then they can easily weasel their way out of payment. But the key thing here is that there is no trust between the two parties. And this is where weather indexed insurance comes in. It's a great tool to take the questions out of or take the uncertainty out of the picture. And weather index insurance, the way it works is basically the insurance policy will pay out if a certain event, an indisputable event, happens. Okay, let me explain what that means. So in this model of the weather index insurance, Joseph will, take a look at his farm and be like, you know what? I think my total crop value is about 1,000, and if there's a drought, I'm going to lose half of it, so I'm going to lose about $500. So he decides to insure $500 worth of crop. He makes this decision on his own. I don't have to send him anybody. He comes to me, he comes to AIG and says, hey, I want to insure $500 worth of crop. I then make an assessment using some computer simulations models of the likelihood of a drought. Let's say it's 10%, and I calculate his premium as being, $50. He pays me the premium, and then he goes on to do his farming. While he's farming, a third party that both of us ideally should trust installs weather stations nearby to monitor rainfall throughout the season. Now, if the rainfall is below some critical threshold at the end of the season, Joseph will instantly get paid money. Okay? So basically, if it doesn't rain, then Joseph gets paid his insurance amount. And if it rains, then he doesn't get anything back. But it's a bit more complicated than that. You see, the payout is usually a formula where if it rains if it rains a little bit, if you only get 10 inches of rain for the whole 3 months, then he's only going to get 50% of his payout. So he's going to get $250. Right? So this is how weather index insurance works. So you have to rely on a proper weather measurement tool to be able to measure rainfall. And then based on that, you give out the payout to the farmer, right? And the unfortunate reality is, in spite of this, farmers like Joseph throughout Kenya, they haven't taken up weather index insurance. The problem is that the trust is still isn't there. I think, as Verlin mentioned, or as Calvin mentioned, they don't necessarily have cash on hand. They don't have that financial security to be able to pay their premiums on time. And they don't, frankly, understand how insurance policies work. I mean, even I don't necessarily understand fully how this works. So it's risky, right? So because we're running out of time, I typically would open this for questions, because I know you probably have a lot of ideas about this. But to de-risk this policy, you can create greater transparency by sending farmers regular SMS messages of rainfall measurements. This would have two effects. Number one, it would assure farmers that the data measurements are not bullshit. That if they're saying that it rained 4 millimeters last night and you're going to get 5 millimeters today, you can actually verify that. So when the time comes to negotiate the settlement with the insurer, you trust that third party measurement company, and you can use that, the SMS messages of rainfall to be able to better take care of your farm. To solve the issue of people not having enough cash on hand, you can sell group plans to the entire co-op. So rather than sell it to individual farmers, you can sell it to a cooperative, so you can cover a larger area. And you can bundle the insurance with other technologies. So one of the issues I said is that a farmer won't buy a new fancy irrigation system because they're worried about what happens if it breaks, or what happens if there's some other event, some natural event that destroys their crop. One way to incentivize people to take up new technologies is to bundle insurance with that technology, so they have a bit of peace of mind that if the technology fails, they will still get a payout. So this is a way of hitting two birds with one stone. Okay. Questions? All right, so we're actually at the end of the lecture. I'm not going to do this. We've already talked about aquaculture, so I'm going to skip this. There's nothing particularly interesting about it. But what I want to do now is I want to lay out a real world agriculture problem for you. And what I want you to do is, you can think about it on your own, or you can discuss it with your team, with your project team. And I'll make this the focal point of next week's discussion. Okay. So check this out and pay attention because this is a really interesting problem. So mustard seed farming is it's, I want to say the backbone, but a very important cultivation practice in Rajasthan in India, right? So mustard seeds is basically where you get your mustard from, your Dijon mustard, right? And it typically grows in these little pods, and when you split these pods open, there's little seeds, and those seeds contain mustard oil. So you just squeeze the oil out of the seeds which are inside those pods. The sad thing is that in India, in Rajasthan specifically, those farmers get ripped off by middlemen, right? This is what the seeds look like, and they typically don't get paid fairly for their crop, right? Especially women. So as a mustard seed farmer, you have one of two options. You can take your crop, right, and this is the most common one, where you don't know the seed quality, you don't know how much oil there is in the seed, and as a result, you can't bargain a fair price. You can go to a middleman, they'll say, you only have so many grams of oil in this batch, but you can't prove them wrong. So you have to accept the price they tell you and sell it to a middleman, and sell it to that middleman, right? The other option is you can pay 40 rupees to get your seeds analyzed, right? And oftentimes you don't get a good result the first time, so you have to pay another 40 to get another analysis. Then you enter an auction to sell your seeds. If you don't get the price you want, either you could lose the 80 rupees and then go home without a profit. The alternative would be to sell to the highest bidder, who would still screw you over, which is often what ends up happening. And so farmers get severely undercut because there's no way to hold the middlemen accountable to give the farmers a fair price on their seeds. And this problem hits women more than men. So for a typical crop, a woman will get 3,400 rupees and a man will get 3,900. So it's 15% less just by dint of her being a woman. So it has nothing to do with the quality of the seeds at this point, but rather has entirely to do with prejudices in the country. And typically, the kind of hardware you would need to test the oil content of mustard seeds looks something like this. It's really sophisticated and very expensive, and illiterate farmers probably don't know how to use it or where to even find it. But this is the kind of hardware that one would typically use to address this problem. So here's a challenge for you. Can you come up with a method to help the farmers ascertain the oil content of their mustard seed crop? So again, can you come up with a way to help smallholder farmers ascertain how much oil there is in their mustard seed crop? Because that will help give them bargaining power against middlemen. Or can you think of some other way the government can hold the middlemen accountable to give the farmers a fair price? So it is 2 o'clock, so I'll let you all go, but I'll post this up as next week's discussion question. It's really fun. I always get really interesting and diverse responses to it, so I'm looking forward to what you guys say. And feel free to answer it as a group. Just tell me the group members. Just tell me, I'm answering on behalf of, these names. And tell me your idea, and I'd be really interested to see. Already Lisa is asking, are the seeds that have oil maybe more, maybe less buoyant? See, she's going to some pretty interesting places. I won't answer that, but it's a very good place to start thinking. So think about it a little bit, and we'll go through the discussion. Now, again, don't forget to keep participating on the online discussions. And on Thursday, we're going to have our lecture about diffusion of technologies. It'll be fun. Next week is our last lecture week, and then the week after we'll do our presentations. So remember, it's video presentations. If you have any questions, I know we're going through some radical changes in the course right now, feel free to email me, and we'll see where we can go. So I'm going to stop recording now. I'm going to post up the recording on Quarkus. And I will see you all on Thursday. Be safe, be healthy, and take care of yourselves. Bye.